All right, in this video we basically just have an introduction to polynomials in general and just different graph properties of polynomials that you should be able to tell from the equation basically. I mean, you can type any of these things into Desmos or your calculator and see what they look like, but the point is to be able to look at a picture or look at an equation and tell some things about it. So all of these pictures up here, these are all polynomials. So polynomials, a parabola is a polynomial, a line is a polynomial. They're just, very simple ones. Most polynomials look like, these, or when people talk about a polynomial, they're usually talking about something like this, where it has lots of, twists and turns. It crosses the x-axis, a bunch of times it can. And all those things are kind of important. Another thing to look at is like the end behavior. So notice like in a parabola, both ends go up. This graph, both ends go up. Here, both ends go down. This happens based on the exponent, the degree of the polynomial, the highest exponent. So let's talk about those a little bit. So first, some words that go with polynomials. All right. So when you have, when you look at a polynomial, the highest power, the highest exponent is called the degree. Okay, and actually there's another exponent here as well, and that is an exponent of, I don't know if I have a brown color, let me see. No, I don't have brown, but whatever. This right here, there's another exponent right there. So there should also be something going right here. That's an exponent. So when you look at your problem or your pieces of your problem, the highest exponent, usually it's the thing in the first spot, but it doesn't have to be in order. The highest exponent is called the degree of the polynomial. Okay, so based on that, you have some words that go with it. When your highest power is a 3, it's called a cubic polynomial. When your highest power is a 2, it's called a quadratic. Highest power is 1 in both of these. It's called a linear. And then you have a highest power of 0, because remember, this could have an x to the 0 next to it. And so basically, that's what a constant is, right? There's also something with, x to the 4th. That's called a quartic. X to the 5th is a quintic. There's names for all of them, but we don't see them that often. So when you have a polynomial, these pieces right here, these are like your terms of your polynomial. All right, you have your operators like addition, subtraction, or addition. The numbers in front of your variable are your coefficients. And when a coefficient has no x after it, so this will be having like x to the 0, that's called a constant. Okay, so just those words come up a little bit. Polynomials, like this one has 3 terms to it. So 3 terms, that's called a trinomial. So this would be called a quintic because it's 5th power, and trinomial. So you'd say, oh, this is a quintic trinomial, like when you would write that thing if you wanted to name it. Binomial has only 2 parts to it, like these expressions here. Monomial is just one thing at a time. And after 3, I guess there's names for them, but then we just start calling them polynomials, all right? So all of these things are polynomials, but when they're only 3 parts, 2 parts, or 1 part, you kind of name them more specifically. All right, last thing on this page here. This is a general form of a polynomial. And so when you see this, don't let it confuse you too bad. These x's here, these are just telling you that, hey, there's x to a power, and then you do x to the power underneath that. So like when you have x to the 5th, the next one would be x to the 4th, then x to the 3rd. And so it just, dwindles down until you get to just plain old x. And then finally over here is x to the 0. Remember I was telling you, like, if there's no x at all, that means it's x to the 0, because we all know that x to the 0 equals 1 anyway. All right, so these x's right here are just trying to tell you that you have x's that are going down a notch every single time with every term. All right, and then this part, this is standing for, these are just random names for the coefficients. So they really don't have to follow a pattern. an is just the name of the first coefficient there, then n minus 1, the next one, all the way down to the very last one. Okay, so this is how you see it in a book, how you see a definition of a polynomial, but it's really just looks more complicated than it really is. Okay, all right, so it's time to tell you something about the exponents and the terms and whatnot. So when you look at these polynomials, I want you to notice that, like here, one turn, another turn, another turn. So imagine you're driving a car and you're like, oh, turn around, turn around, turn around. All right. So every time you have a turn in a polynomial, 1, 2, 3 turns. So let's go ahead and like jot that down. So this one has 3 turns. Now this just tells you something that could happen. So 3 turns. I got 1, 2. This one right here looks like a turn, but I'm not actually turning around, so we're not going to call it a turn. And I have 3 right there. I mean, that middle one's kind of important, but this one's 3 turns. All right, 1, 2, 3, 2 turns. And let's see, 1, 2, 3, 3 turns. And 1, 2 turns. This is just 1 turn. All right. So the number of turns usually indicates the exponent, the degree. So in this one, it's pretty obvious. Like 1, 2, 3 turns means you have a degree of x to the 4th. All right. So one other thing to note is this. Is what is this end behavior doing? Both going up. Let's start with a parabola, both going up. So when you have both ends going up or both ends going down, then that means that you have an even number up top, okay? And so like this one we know is x squared, right? Let's see here. This is another one, both facing up, so it has to be an even. And over here, x2 has to be even. Now, it's based on the number of turns I see. I have one turn, and so the exponent is one higher than the number of turns. So that's why this is x squared. So this one has 3 terms. So this is probably x to the 4th. Now this is probably, okay? And let's look at this one. I know it's an even number because both ends are going down, 1, 2, 3. And so something you don't know yet, but so I'm going to say, hey, there could be a power of 4 here, but this right here, this little slow pass right here, that means that counts. That is going to count for a triple root. And so I see 3 turns, but this root right here is going to be 3 more. So that's going to be x to the 6th. You don't really know all about that yet, but here, 1, 2, 3, and again, this counts for a triple root, that little slow pass through right there. So this is going to be x to the 6th. Now, one other thing to mention, both of these ends are pointing down, so there must be a negative in front of that x to the 6th to make that happen. All right, so let's look at these ones with opposite directions. When you have opposite directions, you're going to have an odd number up here, okay? And 2 turns, you go 1 higher, that means it's a 3. And there's no strange turns in here or anything like that. This one again, 2 turns, so x to the 3rd, and it's going opposite ways. So normally when you have an odd power, the right side goes up and the left side goes down. Well, this one is switched, so there must be a negative in front of that. Okay, we'll talk about more on the next page. All right, let's see what we got here. All right, let's do some of this vocabulary here. So we have a polynomial here, and you do have the equation. And what I did is I had that 1/4 right there. I wrote this x minus 2 twice, and the x plus 3, and I took that and multiplied it all out, and this is what I got. So you don't have to do that right now, but I'm just showing you the different formats. So some things to notice. 2 is a 0, so you see how it's crossing at 2 right here? That's because 2 plugged in there makes a 0. Also -3. -3 is one of the zeros of that factor, so that's why it's crossing at -3. So let's start there. This right here, and these 2 spots are called zeros. They're x-intercepts. Okay, they're also roots and solutions. Okay, so let's go ahead and put that. I should put more boxes. All right. Now also, these 2 spots here and here, they are maximums and minimums, but they're not absolute maximums or minimums. This is just a local maximum, right? Because this is a high point, like a mountaintop, but you see the graph goes higher eventually. And this right here is a local minimum. And you see it's a low point, but the graph does go lower initially, right? What's my end behavior? So as x goes to infinity. So that means as I'm going right, the graph is going up. And this one right here, as I'm going left, the graph is going down. So I'm going to put plus and minus. Now, what I can tell from this, since the ends are going opposite ways, this has to be an odd power. And since I have two terms, that's probably x to the third. And there's no weird little, flat areas or anything like that. So x to the third. And hey, guess what? Look at that. It is x to the third. So that is my degree. Now this number up here, this is a coefficient. And since it's the first one with the highest degree next to it, it's called the leading coefficient. Coefficient. Okay. All right, and then this 3 over here is kind of important. This is the constant term. Okay, so my domain. So think about what numbers you can plug in for x here or here. And you can plug in any number you want, negative infinity to infinity. All right, so what that's telling you also is that this graph exists all the way to the right and all the way to the left. And you can see that this does. It keeps going up to the right and down to the left. All right, and it just so turns out that my graph goes up forever and down forever. So my range is also negative infinity to positive infinity. Now, the domain is always this on all polynomials, but the range could change. So let's look back here. So like, for instance, on a graph like this one, all right, the range, whatever this number is, looks like it's -4. So the range is from -4 up. All right, look at this problem right here. It looks like it's like from 1 up. Okay. This one right here looks like it's from like 4 down, okay? So ranges can be different, but domain is always negative infinity to infinity. All right, local mins and maxes. So let's see this point right here. That's, I'm gonna say about -1.5 and 4.7. We're just estimating here. So -1.5, oops. 4.7, and this guy right here, that's at 2, 0. All right, x-intercepts looks like about at -3 and also at 2, 0. Y-intercept looks like it's right here at 3. So one other thing to note, the y-intercept, plugging 0 into the problem, look how easy that is. You plug 0 in here and here and here, these all disappear. That constant there, that is your y-intercept. Okay, so last thing here, we're going to be able to want to know some things about a graph just by looking at the equation. Okay. All right, so first of all, the thing to do is make sure your equation is in order. And by order, I mean you have the highest power, then it trickles down. So that's called standard form. So this one is the highest, that's next, that's next. So that's not in standard form, and neither is this one here. So this first one is, so degree. The degree is 3. The number of turns is 1 less than the degree, so 2. Now, the number of x-intercepts. So when you have a power, when your highest power is 3, that means you can have 3 x-intercepts possibly, because there's 3 solutions to this problem. They might not all be real, so they might be some imaginary solutions. But when you look at a picture, when you see 3 x-intercepts, then you're like, oh, it's probably x to the third. Now, in some of these, like look at this guy, a parabola has 2 solutions, but I don't see any x-intercepts because these must be imaginary solutions. Look over here, 1, 2, and this one is a double root, right? Because it bounces off. So that's why this counts 2, 3, 4. That's why this is x to the 4th. So those times that you pass through the x-axis, those are solutions, right? And so when you have your power, there's that many solutions to a problem. All right, and they can be real and imaginary. So possible number of x-intercepts up to 3. Now let's talk about the end behavior. This degree is an odd number. And normally on an odd, the right side goes up and the left side goes down. Well, but that's a negative right there. So actually what's going to happen is it's going to switch. So there's my end behavior basically. And so I'm basically just drawing a picture that would represent a statement like this, but all right, so here we put negative x to the 4th first, then my x to the 3rd, my standard form, plus 3x squared minus x plus 3. And you don't really have to do that, but it's nice because then you can see that first term right there for you to get all your answers from. So degree is 4. That means there's possibly 4 x-intercepts. So could be up to 3 turns. So these are possible because it's up to that many. This is the most number of turns and the most number of x-intercepts I'm going to see. All right, so let's try and get an idea. So when you have x to the 4th, this is an even number. So evens mean both sides go up, but there's a negative in front. So this graph has been flipped over, has been reflected, so both sides go down. All right, last one here. I got 7x squared plus 4x minus 6. So hopefully you recognize that. That's just your basic parabola. And the 7 is positive, so both sides are going up. Okay, the degree is 2, number of turns 1 up to, or 1 turn, what we all know, parabola has 1 turn, and possible number of x-intercepts. There could be up to 2, there could be 1, there could be 0. Okay, so these are just things that you're supposed to kind of get from an equation, or also things that you're supposed to get when you're given a picture, things you're supposed to know.